Okay, so today we're just going to be looking at some general titration experimental procedure, just as revision for the test coming up, because these are the sort of things that I, for lack of a better description, could ask you in a test. So we need to know what sort of glassware is. You need to know how to identify glassware. So I'm just going to poorly draw a few things. So there's not the best drawings. That last one I might just redo. It's a bit atrocious. Alright, not much better than that one there, but hopefully we all get the idea. Okay, so I'm just going to add some little things in here. Yeah, look, we know what's going on. We're all good. Okay, so obviously you need to know how to identify these. So maybe just pause the video here and take a moment to think about what each one is. So yeah, have a pause and go from there. All right, so our first thing here is a volumetric pipette. Our second thing here is a burette. Our third thing is a volumetric flask. And our fourth is a conical flask. And the sort of things you need to know in a test situation or just in any sort of laboratory situation is say the name of these, identify what they are. And just what they're used for. So a volumetric flask, it's used to transfer an aliquot, the keyword there, of solution. What's an aliquot? To read straight off a definition of that one. An aliquot of a sample in chemistry is an exact portion of a sample of liquid. So, for example, exactly 20 milliliters of solution. So hence, a volumetric flask transfers an exact sample of solution, so an aliquot of solution. What does a burette do? A burette, so maybe just pause here and just think about what each of these do, come up with an answer, and then resume. So assuming you've done that just now and we've resumed, a burette transfers a variable volume of solution. And that makes sense, doesn't it? Because, we use our tap here to determine how much volume goes into, the conical flask at the bottom. So it's a variable volume. What does a volumetric flask do? It makes up a standard solution. To an exact volume. Usually make up a standard solution, and what's the definition of a standard solution? And again, just to go straight off a exact definition to read one out to you. A standard solution is a solution containing an accurately known concentration of substance or solution. Cool. Conical flask, it's pretty much just your reaction vessel. if anyone's curious, the reason we use a conical flask is because it does bottleneck off at the sides like this. It means that, if there were to be a combustion or something here, or some, a reaction that was very, violent and vigorous, instead of it going straight up, it gets, restricted to just coming out of this little top piece here, as opposed to if you used a beaker where it would all just come out and go everywhere and make a real mess and could be dangerous. Anyway, that's not really something I really care to test you on too much. So you need to obviously know how you're going to prepare each piece of glassware. So to prepare the volumetric pipettes, we're going to, so maybe just pause here and just write down how you prepare each piece of glassware and resume once you've got an answer for each one. So to prepare a volumetric pipette, we're going to rinse with distilled water, and that is to remove any contaminants. So it's, effectively so it's clean. But then once you rinse with distilled water, you're gonna have, little bits of water residue kicking around on the inside of it. We obviously don't want that. Why not? Because if you've got residue water there, then you're going to, if you've got residue water, it's going to lower the concentration of it, because your 20 mils or your 25 mil sample is now going to have some water in it, and therefore it's really going to be 24.2 mils because there's 0.8 mil of residue water there, for example. That is example numbers. So we're going to familiarize it with the solution being transferred. And why? Because as we said, to remove residual water there, to make sure that our results are accurate, we don't want to dilute our solution being transferred in there with water. Okay. For a burette, same again. Rinse with distilled water for the same reason, to remove contaminants, to clean it, and then familiarize with the solution being transferred. Again, just to make sure we're not diluting our concentration of our titer. Fantastic. Standard solution, how do we prepare that? We're going to rinse with water. Distilled water again to clean it, and that's going to remove any contaminants. That's all we're going to do. Reason why, we're not going to familiarize it with anything, because if we familiarize our volumetric flask, if you familiarize it, you're putting in little bits of residue of a solution in there, and that's going to put moles in there to start with, which is going to change our concentration. If anything, it's going to increase our concentration, or it could be the wrong solution, therefore that'll react and whatever that does. If there's residue water in there, does it matter? No, because this is being made up to the mark with water anyway, and obviously that's going to be with a nice meniscus. It's going to be made up with water anyway, so if there's already little bits of water, kicking around on the edges here, it doesn't matter because it's being made up with water anyway. The important thing to remember, if we're putting a mass in here, we put our mass in first, and then we make it up with water. If you make it up with water to the mark to start with, and then add your mass, that volume is going to slightly increase, and therefore you're going to have an incorrect standard solution. Conical flask. Rinse with water. Again. And once again, doesn't need to be familiarized with anything. Doesn't even need to be dry, because you put your analyte in here, so you might put your 20 mils of acid in here. If some water goes in here, it doesn't matter, because the moles of acid isn't changed. Alrighty. So we now know what our experimental pieces are. We know how to rinse them. We know that we're going to read the meniscus as shown, like that, like that. Just trying to think of other things I might ask about these, other definitions I might want you to know.